Okay, so we're back. This is our only real calculations of the chapter. We are going to use some natural logs. You're going to need a calculator, so you definitely want to pay attention to this because it's kind of your first math. So what we're going to do is we're going to use this equation, and up top there you can see that there's this rate equation, and it equals Kn. Well, it's not that useful. So what they did is they did a derivation, and I'm going to give you the derivation, and they came up with a more useful equation that looks like this. So they have ln is n sub t over n sub 0 equals negative k times t. And this is the equation we're going to be using throughout this whole kind of time. So you probably haven't seen all these things before. If you don't know ln is a natural log. It's a mathematical function that you're going to use your calculator for. And it's sort of like regular log, but based on a different base. T is going to be time, so how long are you letting it sit? K is your decay constant, and we'll get to that in 1 second, how we get that decay constant. N sub 0 is how much do you initially have? So you start with 100 grams. And N sub T is how much do you have at the end? So if I let it sit for 27 years, how much do I have at the end of that? And then the last thing we need to do is say, how do we get this the K? And the way you get K is K is 0.693 over the half-life. And T1/2 is the half-life. So they'll say the half-life's 27 years. Well, then you would plug 27 years into the bottom here. We're going to do two problems where you kind of work through it. You have to be able to use the equation, you have to be able to do some simple algebra, and you have to kind of think things through for this. And down at the bottom here, you probably want to write this down. If you have to undo a natural log on your calculator, you're going to use e to the x. It's the same button as the natural log. It's usually second natural log. So you need to look on your calculator and find that. All right. The first one, we're actually going to, the first one in your note packet has about like uranium-238. Just skip that. We're not going to do that one. We're going to start at number 2, and it says if we start with 1 gram of strontium-90, we know how much will remain after 2 years. So what you have to do with this is it's a half-life problem, so you know you're going to use this equation, natural log of n sub t over n sub 0 equals negative kt. We have to see what do we already have. So it says if we start with 1 gram, well, what we start with is n sub 0. So that's going to be our n sub 0, 1 gram. And it says we are going to have 0.953 grams after 2 years. So that's how much is going to be at the end. So that's n sub t. So n sub t is 0.953 grams. And it says how much is going to remain after 2 years. So we're going to let it sit for 2 years. So that's our time, 2 years. And then the question is, what's our half-life? So that's our unknown. So we're going to look at our equation and plug in. So we have natural log of 1.000 grams over 0.953 grams equals negative k, we don't know k, times t, which is 2 years. So you have to be careful and actually look at your equation and say, what can I do? If you look on the left side, you can actually put that in your calculator and get a number. So you would hit the natural log button. You'd have the 1 over, oops, I just realized I totally flipped this upside down, so I apologize. So we have natural log, of 0.953 grams over 1 gram. Sorry about that. But again, if you look at that left side, you can put that in your calculator and get a number. So if you put in natural log of 0.953 over 1 gram, you will get a number, and you'll get negative 0.0481. And if we just say the left side, the right side is going to be negative 2.00 k. So then all we have to do is, our unknown is k. So if we solve for k, it's going to be 0.0241 k. So now that's our decay constant, but we want our half-life. So we have to think back and say, what's that equation for K? Our equation for K is 0.693 over our half-life. So if we use this K we just got and we plug it in, we can get our half-life. So 0.0241 equals 0.693 over our half-life. Use your algebra, get your half-life off the bottom. And we're going to get that our half-life is 28.8, and we're dealing with years, so our half-life is in years. And that's your answer. But you have to be able to read the problem and plug it into the equation, and then see what do you still need to find. So that's one type. And then the second type, and this is the last thing we're doing. Oh, here we go. Here's an extra one. How much is going to remain after 5 years? So this time is a little different. So you look at what we still know. Our n sub 0 is still 1. We already solved for k. We just solved for k up above, so we're going to put that in, 0.241. And this time, our time is going to be 5 years. So what we're going to do is we're going to plug it into this equation again and see what we have and what we need. And if you look, we don't know how much is going to remain at the end. That's our n sub t. That's our question mark. So we plug into our equation. We have natural log of n sub t over 1 gram equals negative 0.0241 times 5. And what you're going to notice this time is we can't just put the left side of our equation into our calculator because we have this n sub t that we don't know the answer to, so we can't just get an answer for that. So we're going to have to kind of leave that alone. So I'm just going to rewrite this. This is kind of going to be a pain. And I'm just going to simplify my right, so I'm going to multiply them together, and I get negative 0.1205. Now the problem is how do we fix this left side? Because we can't put natural log of an unknown in. So if you remember, we can undo a natural log. And the undoing of a natural log is e. So if we're going to put an e to the left side, we're going to have to do e to the right side. When an e and a natural log hit, they disappear. So we get n sub t over 1 equals e to the negative 0.1205. And you'll actually have to put that in your calculator. And you'll actually put an e to the negative 0.1205. And what you're going to get is you're going to get n sub t over 1.00 equals 0.8865. And then we want to solve for this n sub t, so we multiply both sides by 1, and we get 0.887 grams. The tricky thing is you have to be able to put this in your calculator, and you have to see when it's appropriate to use. So when we can't just put that natural log in and get an answer, we're going to have to use e. If we don't need to use e, we're not going to. And then very last problem we're going to do is basically one more time. So it says that we have a 100-gram sample. So that's our very beginning. That's our n sub 0. And we're going to use it for medical imaging. And it has a half-life of 110 minutes. So that's T1 half is 110 minutes. We want to know what percentage of the original activity remains after 300 minutes. So, all right, we're letting it sit there for 300 minutes. That's our time. And we want to kind of figure out, we want the percentage, but we need to know how much is left. So n sub t is kind of our unknown. So we look at our equation. And you see, we have everything but k. So the first step we need to do is we need to get k. So what we're going to do is we use our k equation, and it's 0.693 over our half-life, which is 110 minutes, and it's 0.00631 over minutes. So now we have everything we need. We can plug it into our equation. So we have natural log of n sub t over 100 grams equals negative 0.0063, 1 over minutes times 300 minutes. So again, you have to look at it and say, what can I do? Can I put that natural log into my calculator? We can't because of that unknown, that n sub t. So we're going to let it alone for a second. Just bring it down. And then work on our right side. So if we multiply the right side together, we get negative 1.89. And now we say, okay, now we have to do something. And we say, how do we get rid of that natural log? That's where the e comes in. So we're going to put an e on both sides. The natural log and the e drop. So we have n sub t over 100 grams equals e to the negative 1.89. You do your math. Equals 0.151. You solve for n sub t, which is 15.1 grams. So that means at the end, we're going to have 15.1 grams left. We want the percentage. So, okay, if we have 15.1 grams left out of the original 100, we have 15.1% left from what we started with. So with these, you have to look at it and be able to read the problem. You have to be able to use the equation and really think through. So you're going to practice these now because they can get a little tricky, and you want to make sure that you can actually solve the problems.